Hello viewers, welcome back to channel enginiusmechtech. I hope you're all doing well. Today we are starting our new chapter. Chapter name is Machining Operation and Machine Tools Part 1. In this chapter we will discuss about machining operation and machine tools, turning and related operation, drilling and related operation, milling, machining centers, turning centers and other machining operation, HSM, high speed machining. Machining is basically the removal process in which sharp cutting tool is used to mechanically cut away the material so that the desired part geometry remains. Most common application to shape metal parts, machining is basically the most versatile and accurate of all the manufacturing process in its capability to produce a diversity of parts, geometries and geometric features. For example, screw threads, gear teeth, flat surfaces. Casting can also be produced a variety of shapes, but it lacks it lacks the precision and accuracy of machining. Classification of machine parts can be divided into rotational, that may be cylindrical or disc-like shaped, achieved by rotation motion of work part, for example turning and boring, and non-rotational. It is also known as prismatic, block-like, or plate-like because it cannot achieve the desired part by rotation. It can be done by milling, shaping, planing, and sawing. Machining operation must require a relative motion between tool and the work part. Generating part geometry is determined by the feed trajectory to cutting tool. Feed motion creates shape, etc. For example, straight turning, taper turning, profile milling, and maybe many other processes. Shape of cutting tool forming forming is termed under the category of shape of the cutting tool because the part geometry is created by the shape of cutting tool. Cutting edge has reverse of the shape to be produced on part surface. For example, form turning, drilling, and broaching. Forming and generating are sometimes combined in one operation, such as in thread cutting on a lathe and slot milling. This is simply turning, this is taper turning, this is form turning, this is milling and form milling, profile milling. This is form tool, the reverse shape of the required is on the form. This is the drilling and this is broaching. This is the motion. This is the threading operation, form generated surface. This is a single point threading tool. This is T-slot milling tool. Turning, a single point cutting tool removes the material from a rotating workpiece to generate a cylindrical shape. The tool is fed linearly in a direction to axis of rotation. Performed on a machine tool called lathe. It can be performed on lathe machines. Lathe machine is a machine in which we perform different operations. These operations can be performed on the lathe, facing, contour turning, chamfering, cutoff, and threading, etc. This is some terminology I have discussed previously in the previous lecture, but I will tell you again that this is the cutting tool, this is the feed, and this is the rotational speed. The number of speed is given by V, rotational speed, divided by pi d naught. D naught minus df is 2d, and MRR, material removal rate, is given by VFD. Facing. Facing is an operation in which the tool is fed radially inward. This is the facing process in this to plane the end surface of the work part. This is known as facing. Contour turning, instead of feeding a tool parallel to the axis of rotation, the tool is follow the contour. This is the shape of the tool to form a shape on the work part. This is known as contour turn. So next is chamfering. Cutting edge cuts an angle on the corner of cylinder forming a chamfer. This is an angular cut to give an angle at the end of the work part. Cutoff tool is fed radially inward to separate the work part into two pieces. Sometimes it is used for separating the two pieces, but sometimes it's just for the a little bit slotting. It is also known as slotting or parting. Threading is the single pointed tool fed inward and feed is given at high rate. High feed is given to this tool, and the work part is and the threads are formed on the work part. This is facing process. This is taper turning. contour turning, form turning, chamfering, cutoff, threading. The boring is internal, drilling, and knurling. The engine lathe. Diagram of an engine lathe. Engine lathe is known as lathe machine. This is the headstock, spindle. This can be the feed. This is the tool post, tailstock, bed, and many other parts. This is the feed controls. This can be varied with the types of machines. This is another visualization of the lathe machine. This is the compound rest. Lathe machine. Most of the lathe machines are horizontal, but vertical lathe machine also be used for some jobs. The size of lathe designated by swing and maximum distance between centers. Swing is basically the maximum work part diameter that can be rotated in the spindle, and distance between centers is clear from that is from the head to the tailstock, headstock to tailstock. Uh, if just for example, 350 mm cross 1.2 meter lathe means a swing of 350 mm and maximum distance of 1.2 meters. Method of holding the work in a lathe. There are four common methods used to hold work part in turning to grasp the work. Center and support it in position along the spindle axis and rotate it. Hold the work between the centers, chuck, collet, or the faceplate. These are the four holding methods. First one is the holding work part between the centers. This is the headstock and this is the tailstock. This can be holded like this. This is a dog plate, the dog work part centers. This is the holding the work part between centers. This is the chuck. There may be two jaw chuck, three jaw chuck. Sorry for two jaw chuck. There is no two jaw chuck. There is three jaw chuck and fourth jaw chuck. This may be dependent upon the some things. Collet is the another kind of holding device. Collet is a tabular bushing with a longitudinal slits running over half its length and equally spaced around its circumference. When it is pushed, it can this area is pushed in radially inward to hold it tightly because it squeezes. These things are squeezes. Faceplate is similar to the chuck, but in this there is a special kind of plate for the unique shape of the work part, because in the previous case there is no uniqueness. There is similarly cylindrical parts. There are some other lathes and turning machines like tool room lathe, speed lathe, turret lathe, checking machine, automatic screw machine, numerically controlled lathe. Lathe is basically the lathe machine that is manually operated with the tails and in which the tail stalk is replaced by turret. Turret is the thing that holds multiple tools for the job, and it can be used and can be simultaneously change the tools for the further processes. Tool rapidly brought into action by indexing the turret. Tool post replaced by four-sided turret to index four tools. Applications include the high production work that requires a sequence of cuts into the parts. This is basically the turret lathe. As you can see, this is the square turret, this is the hexagon turret. We can replace it by moving into different sides by manually, and sometimes in CNCs it can be automated with the computerized numerical control CNCs. Example of turrets are below in the image. This is the number one turret. This is some kind of another tool. This is another tool. This is another tool. This is the 8 tool turret. This is 6 tool turret. These are all the kind of turrets. Okay. Chucking machine. Chucking machine uses chuck in its spindle to hold the work part. In this machine, no tail stalk is required, so that the part can be mounted completely in the chuck. Cutting tool actions controlled automatically. Operator's job to load and unload the part. Application are short and lightweighted parts. Heavy parts cannot be deal in this chucking machine. Bar machine. Similar to chucking machine except the collet replace the chuck. These are not the kind of things. Automatic screw machine same as automatic bar machine but smaller. Application is high production of screws and similar small hardware items like screws and some other like screws. Hence its name is automatic screw machine. Multiple spindle bar machines are the more than one spindle is so multiple part machines simultaneously by multiple tools. Example, six spindle tools and bar machines work on six time at a time. After each machining cycle, spindle, including collets and work parts, are indexed to next position. This is first tool is used to for this process bar stock. Then second is turning tool, then third is form tool, then fourth is drilling, then chamfering, and finally the cutoff. This is the process that can be done with the six-spindle automatic bar machine. Finally, the computerized numerical control lathe. This can automated by CNC unit, so it is not a big deal. All the processes are similar to simple lathe, but this is automated. This can be done with the program and algorithms numerically controlled and computerized numerically controlled. Boring. Now next process is boring. This is similar to turning, but in this the single point tool against the rotating work part. What is the difference between turning and boring? Boring is performed on the inside diameter of an existing hole. Turning is performed on the outside diameter of an existing cylinder. Boring is an internal turning operation and turning is simply the outside. Machining tools used to perform boring operation are called boring machines, and this is not a big deal. Horizontal boring is in horizontal direction and boring bar between centers. This is another kind. This is simply this way, and this the feed motion is given to the tool, and in this also. Vertical boring mill is in the vertical direction. In this the tool is moving like this and work part is rotated like this, and this is the enlarging exaggeration of the existing hole. Drilling is the process machining operation used to create a round hole. Boring is enlarging the hole and drilling is creating a hole. Cutting tool is called a drill or drill bit, customarily performed on the drill press. Cutting condition in drilling is like simply the N is equal to V by pi d. V is the feed speed, cutting speed. MRR, material removal rate, is equal to pi d square. FR is the feed rate, and by 4, where feed rate is given by N into F. These are some simple terminologies. These you can be say this is the point angle, rake angle, cutting edges, and chisel phase. These are simply the some things like that is not a big deal. Through holes and blind holes. Through holes, when the drilling is performed, it is completely crossed. The work part is known as through hole. Blind hole is not crossing the work part. In this, the tool is completely passing through it. In this, it is not passing the work depth. Operation related to drilling. There are many operations that are related to drilling processes in which a hole must be made first by drilling and then the hole is modified by one or any other operations that may be reaming, tapping, counterboring, countersinking, centering, spot facing. We will discuss it one by one. First of all, reaming. Reaming is used to slightly enlarge a hole, provide better tolerances on diameter and improving surface finish. This is the first hole, and in the reaming, a little bit's diameter is enlarged. So this is the thing. Tapping. Tapping is used to provide internal screw threads on an existing hole. Tool is called tap. In this, the threads are given to internal surface by rotating in a way and rotating the tool. In counterboring, it provides a step hole in which a larger diameter allow a smaller diameter partially into the hole. This is smaller, this is larger. It is used to seal a seat bolt head on the hole. And just like in the tables, in wooden tables, there is a head and there is a space to make head of the nut placed. Countersinking is like this. Center drilling is step in this way, and spot facing is cleaning up upper surfaces. Drill press is similar to the milling machine. In this, the drill press machine tool for drilling. Upright drill stands on the floor. Bench drill is on the bench. It is smaller. This is radial drill. This is gang drill, in which the multiple drill bits are working at the same time. Multiple spindles, and CNC turret drilling machine, in which the many drilling bit are working at the same time. Work holding, it can be done with the vise. This is simply a work holder, fixtures, and some drill jig. These are not too much important. Milling, it is important. A machining operation in which the work is fed past a rotating tool with multiple cutting edges. Axis of tool rotation is perpendicular to feed direction. Create a planar surface. Other geometry is possible either by cutting path or shape. Owing to the variety of shapes possible and its high production rates, milling is one of the most versatile and widely used machining operation. Milling is an interrupted cutting operation. The teeth of milling cutter enters and simultaneously exits the work during each revolution. Cutting tool called a milling center. Milling cutter cutting edge is called the teeth, and machine tool is called the milling machine. Basic, there are two types: peripheral milling, that is like this, and face milling, in which the axis of rotation is perpendicular to the surface. This is the same thing, cutter axis is parallel to surface, and in this cutter axis is perpendicular to surface. Types of milling. In the subdivision of peripheral milling, there is slab milling, slotting, side milling, and straddle milling. In the face milling, conventional milling, partial face milling, end milling, profile milling, pocket milling, and surface contouring. This is the slab milling, in which the cutter is sometimes a little bit greater than the work part. Like these edges are outside the work part. This is known as slab milling. Slotting, in this the cutter is small but the work is large, and it is making a slot in the work part. This is side milling. This is straddle milling, in which the two cutters are working at the same times. Conventional face milling is simply the turning over the work part, cutting overhangs on the both sides. And milling operation may be, if the cutter rotation is in this direction, this is known as up milling or conventional milling. And if the cutter is moving inside, this is known as down milling. This is the chip length higher. In this, the chip length is a little bit lower. In this, the feed direction is this, and in this, the feed direction is moving toward the moving cutter. Type of face milling. Face milling includes conventional milling and partial face milling. This is the partial face, and this is conventional full face milling. End milling. The cutter diameter is less than the work width, so a slot is cut into the part. Majorly end milling is used. Profile milling is giving the shape to the some work part by the peripheral cutting. So this is in this the cutting tool is cutting at the outside periphery of the flat part. Pocket milling is a is a form milling in which, just like the pocket is made in the some work part like slotting, but slotting is another thing and this is another thing. Surface contouring is the ball nose cutter that is used to make a contour on the upper surface, and this is the curvilinear path for the closed intervals to create a 3D-like structures. Milling cutter, this is the cutting edge, this is internal fillet, and that one, this one and this one is the clearance angle. There is an angle between these two lines are known as clearance angle for this, and in this it is known as relief angle. And this previously is known as the radial rake angle. And from here to here is a cutting diameter. And is similarly the V is equal to pi d and MRR is equal to W d FR. Milling machines must provide a rotating spindle for the cutter, table for fastening, positioning, and feeding the work part. Types are knee and column milling, universal milling machine, ram mill, bed type milling, planar type, tracers, CNCs, etc. Overram arbor. There is an overram. This is known as overram. This is the work table, and the speed motion is given in the this direction. This is the saddle, and this is the knee. This is the base, and this is the feed. Column is for supporting the complete body, and this is the cutter that is placed on the saddle, placed on some kind of arbor. This is the complete milling. This is the vertical knee and column milling. This is RAM type. This is milling machine, universal milling machine. This is simplex bed type milling machine. You can see it by yourself, that are not a big deal. Machining centers, highly automated machines, tools capable of performing multiple machining operations under CNC control in one setup with minimal human attention. Typical operation are milling and drilling. 3, 4, or 5 axis machines are used. Other features include automatic tool changing, pallet shuttles, automatic work part positioning. These are universal machining centers, Cincinnati, Milacron. This is the highly automated, capable of multiple machining operation under computer numerical in one setup. Minimal human attention. Required minimal human attention. Mill turn centers, highly automated machine tools. This is the similar thing as previously. This is the a part made from multiple operations. This is first of all we perform turning, then milling cutter is for this flat surface, then drill bit is used for making a hole, and then slotting or parting or cut off. So that's all for the machining operation 1, and I hope you will understand all the things. If you have any queries, any question, put in the comment box. I am here to answer your all the questions. If you have any queries, I will make separate videos for that. Till then, take care and do subscribe my channel Ingenious MacTech.